Hi everyone. So this is the asynchronous portion of today's lecture. Hopefully you were able to join us for the live portion where we discuss human population growth. For the second half of lecture, it'll be asynchronous, so you're able to listen to this on your own time. This material will be part of your midterm exam. So today we're going to be talking about solid waste generation and disposal. One consequence of having so many people on the planet and our population growth really exploding, like we discussed today, is that all of those people are generating massive amounts of waste using massive amounts of resources. So today we're going to be talking a little bit about the waste we generate and the different ways we dispose of that waste. So humans are unique in an ecosystem in that we're truly the only species that generate real waste. Waste is defined as any non-useful products of a system. So in nature, typically you see the waste of one organism becoming a source of energy for another organism. An example of that is can be seen in these food webs. So you should be familiar with this from lecture last week. You can see that for example, zebra may eat the grass, the hyena may eat the zebra, and then the hyena may also eat like a dead organism. That dead animal is then broken down by bacteria and microbes, insects, returns to the soil where it feeds the grasses, which then goes to feed the zebra, etc. So in true food webs, there's actually very little waste. Almost all is used as an energy source for another organism and ultimately ends up back in the ecosystem. Humans generate waste that truly cannot be used by any other organism, and that's what makes us really unique in an ecosystem. So not all of this waste is created equal. We can look at this chart that shows the amount of time it would take for these different items to break down naturally in the environment. For example, let's look at a glass bottle at the very top of this list. If you had a glass bottle, like a wine bottle, for example, and you buried it in your backyard, that glass bottle would remain in your backyard for 1,000,000+ years. It does not break down into smaller components naturally by different microbes or the biota. If we go down the list, for example, an aluminum can, it would remain in the environment for 80 to 200 years before being broken down. Tin cans, 50 years. Leather, 50 years. Plastic bag, 10 to 20 years. And then we get towards the bottom of the list where we start to see some of these items break down relatively quicker. An apple core takes 2 months to break down into the environment. Newspaper, 6 weeks. Paper towel, 2 to 4 weeks. The items at the very bottom of this list we consider biodegradable, meaning that they break down in the environment. And the items at the top of the list are not biodegradable. They do not break down in the environment. It's especially important that we recycle or try to use these non-biodegradable items sparingly, because once we dispose of them, they are going to be in the environment for even up to 1,000,000 years, which is an unbelievably long amount of time to think about how long our waste lasts after we generate it. So until a society becomes wealthy, it actually generates very little waste. For example, picture a family a century ago. If they had a wooden stool and the stool broke, maybe they used that wood to make a bookshelf. If the bookshelf then broke or they didn't want it anymore, they would maybe break down the bookshelf and use that wood to build a fire. Once we start generating the amount of wealth in a society where we can throw an item away and buy a new item, we don't need to think of a new use for that item, that's when we start to generate more waste. In the United States specifically, we really started to see our consumption patterns change after World War II specifically. This is when we started to see the rise of the housewife and making everyday life for a stay-at-home mom as easy and as simple as possible. So you start to see things like disposable diapers, TV dinners, disposable plates, and silverware were really marketed to the stay-at-home mom. Also, after World War II, we wanted to get people back into work. And so if you have many more disposable items, people need to make these in factories. When people throw items away, they need to buy a new item. So it was beneficial for people to have these disposable items because that meant people were purchasing more items more frequently, which meant more jobs. So that's when we really started to see a drastic increase in how people consumed items and how much waste people generated in the United States shortly after World War II. An important term that really explains a lot of how we consume items in the United States specifically is called planned obsolescence. So planned obsolescence is when you design a product so it will need to be replaced in a few years, either because the product becomes unfashionable or it's no longer functional after a specific period of time. So a perfect example of planned obsolescence is the iPhone. So we have 2G iPhones, 3G, 3GS, 4, 4S, 5. This graphic is not that old, and now I think there's probably 6 or 7 new versions of the iPhone. So it's to Apple's benefit to work planned obsolescence into their iPhones, meaning every year or two they come up with a new version of the iPhone. So the old version is unfashionable and the old version may not be supported anymore. So they're really forcing people to buy new cell phones much more quickly than your cell phone needs to be replaced. Another example is with ink cartridges for printers. Oftentimes you'll have your printer will alert you that you've run out of ink, but if you took out that ink cartridge and looked at it, there's still quite a bit of ink at the bottom of that cartridge, but it can't be used anymore. The cartridge is designed so it does not use 100% of the ink. The companies are designing these products like this on purpose, so you'll need to buy them more frequently. So it's really like a design feature a lot of these companies are putting in their products to make people want to buy more because the old version is just not cool, no longer fashionable, or it just doesn't work anymore. So this is a really big factor in why we are such strong consumers in the United States. This is just a picture to really kind of like drive home how planned obsolescence is a really kind of a crazy topic. This is a picture of a light bulb that has been burning continuously since the year 1901 in a firehouse in California. So we do have the technology to build these products so they last for a very, very long time. I mean, this light bulb is over a century old. But it's not to the light bulb manufacturer's advantage to make light bulbs like this, right? They want their light bulb to eventually burn out, so you need to buy a new one. But we do have the technology to really make products that are very long lasting. It's just not financially, doesn't make financial sense for the companies to produce products like this most of the time. So the term I'm going to use instead of garbage or trash, the technical term you would see in the literature is municipal solid waste, or MSW. This is the term that describes the refuse that's collected from households, small businesses, and institutions like schools, prisons, municipal buildings, and hospitals. So that's really just the technical definition for the things that we throw away in our house and in our workplace. In 2008, an average of about 4.5 pounds of MSW of waste was generated per person per day. So if you took all of the waste you generated in one day and weighed it at the end of the day, the average person, their waste would weigh about 4.5 pounds. All things are not equal across the planet, of course. Some people in countries produce more waste than others. In Canada, the average Canadian produces 2.13 kilograms of waste per day. United States, they produce just under 2 kilograms of waste per day. If we look at some of these other countries that produce much less, Ghana, for example, produces 0.09 kilograms of waste per day, so a fraction of the amount of waste that we produce in the United States. Interestingly, typically you see island nations producing much more waste than, for example, in the United States or in Canada. So like the Solomon Islands, average person in the Solomon Islands produces 4.3 kilograms of waste per day, more than twice the average American. Tonga, 3.71, Vanuatu, 3.28, Fiji, 2.1. One reason you see a lot of these small island nations producing a lot of waste is just because they do not have the recycling or garbage facilities that we have in the United States, for example. No one and very few people are coming around with recycling trucks picking up your recycling in the Solomon Islands, for example. And these island nations generate a lot of waste, and it's very expensive for them to ship their waste off the island. So they do not have the same facilities that we do in the United States, which is one reason that they end up producing much more waste than we do. Okay, so in the United States, we produce about 2 kilograms of waste per day, the average American does. If I were to take that waste and categorize it, the greatest type of waste by composition would be paper. So paper makes up 31% of all of our municipal solid waste. If I were to categorize that even further, I would see that the greatest source of municipal solid waste is containers and packaging. So in this course, anytime I show you guys these pie charts, one question I like to ask on an exam would be the greatest section of the pie. So I want you to know the number one breakdown of MSW by composition is paper, and I want you to know the number one source of municipal solid waste is containers and packaging. And this section of the pie, containers and packaging, is just going to continue to explode in recent years because of how much online shopping we're doing. So this, even in our own lifetimes, is going to increase significantly, especially during the pandemic. Think of how many packages you've probably gotten from Amazon, and what you do with those packages, you typically throw them away, or all of the packaging within the box you throw away. So this percentage, as we start to see more and more online shopping, fewer in-person trips to stores, is just going to increase even more. Just some examples of that containers and packaging, some especially egregious examples. The upper left-hand corner is just a picture that I can't even believe is true. But this type of packaging, individually packaging bananas in styrofoam and plastic being some of the worst and least biodegradable items that's going to remain in the environment for a very, very long time. And bananas, frankly, come in their own packaging with the peel. It's ridiculous that you would package a banana. We've all gotten boxes from Amazon, for example, where you order one very small little item and it comes in a huge box with tons of these, maybe like styrofoam peanuts. That's so wasteful. Or we order one small little electronic and it comes in a very big plastic packaging. So this is our biggest source of municipal solid waste, containers and packaging. So it also has the greatest potential to reduce that waste. And we need to design packages better and make sure we use them only when necessary and that they're made of recyclable materials. So one very small section of that pie is something called e-waste. E-waste stands for electronic waste. So that would be things like if you throw away your TV or your computer or your cell phone, any type of electronic, it's called e-waste. It only makes up 2% of the waste stream, so very little of this is actually thrown away, but it's a growing category and it's extremely toxic. So because of planned obsolescence, new technology is being produced all the time. We're getting new iPhones, new computers, and a lot of people are just throwing away their old, more obsolete electronics. It has huge environmental and health concerns because these electronics contain toxic materials, specifically heavy metals such as lead, cadmium, and mercury. And if these get into the environment, they are extremely dangerous to animals, plants, and humans. Very little electronic waste is recycled. Less than 20% of the computers that are thrown away in the United States were recycled in 2007. I'm not sure if you guys, if you had an old cell phone, for example, I always ask the students what they do with it. A lot of students say they give it to somebody else, which is great. Some people say they don't know what to do with it, so they just keep it in an old junk drawer. That's a common way as well. I would hope you don't just throw it into the trash because that's when it can cause a lot of environmental concerns if it ends up in a landfill. But even if you are recycling your electronics, a lot of that e-waste that's recycled is often illegally exported to other countries. It's sold illegally. One of the major countries that is a dumping ground for the developed world that ends up with a lot of these old broken computers and cell phones and televisions is Ghana. So Ghana has truly become a digital dumping ground for a lot of these Western countries. Workers in these countries are exposed to serious health hazards. So in Ghana, they'll receive just huge shiploads of old televisions, cell phones, and computers that do not work. Oftentimes, children take these old electronics and they light them on fire. They burn them in order to access the metal cables inside of the electronics, the copper that they can then sell for a little bit of money. But when you're burning these electronics, you're breathing in those toxic fumes. It is extremely dangerous to the people's health. There is a link to a video on the PowerPoint if you're interested in this. If you're studying computer science, for example, maybe this would be a really good way to tie environmental science into your major. So I'd really recommend you guys watch this short clip that is on the PowerPoint that'll be posted on Blackboard about Ghana, and you really need to see some of these images to just really understand you know, when you say you're recycling your old laptop, it could end up completely on the other side of the world, causing a lot of environmental damage. Okay, so what can we do with this waste? What is a better option than throwing our trash away is recycling. So the 3 R's stand for reduce, reuse, recycle. Anything to divert materials from the waste stream is something positive that we can do. Reduce, reuse, recycle is a phrase that seems like it's been around forever, but it's actually relatively recent in the 90s. Of these 3, reduce, reuse, and recycle, which is the most desirable from an environmental standpoint and which is the least? The answer to that question is reducing is the most desirable in terms of from an environmental standpoint, followed by reusing the item and then recycling. So they're actually in the order of what is best for the environment. Reduce, then reuse, then recycle. Okay, so reduce. Reduce is the best way to achieve a reduction in solid waste generation. It's all about minimizing the amount of waste we create, preventing that waste from being generated in the first place, and reducing the ultimate source of that waste. So an example of how we could reduce the amount of waste we generate is printing our pages double-sided rather than single-sided, or not printing them at all, maybe using electronic copies versus hard copies. So you're reducing the amount of paper you use in the first place. That is the most beneficial option for the environment. If we can't reduce, we should try to reuse. That is the whole idea of reusing something more than once before we throw it away. We want to allow the materials to cycle through the system longer before they actually become waste. So if we use that paper example again, the idea would be to use that unwanted paper as scrap paper before ultimately throwing it away or recycling it. So the third option, still a good option, but of the 3, it is the least beneficial for the environment, is to recycle the items. That is when we take the material, we collect them at a recycling plant, and they're converted into raw materials used to produce new objects. There's 2 categories of recycling. Recycling can either be called closed loop recycling, which is when you recycle a product into the same exact product again, or open loop recycling, which is when you recycle a product into a completely different product. In the United States, we recycle about 1/3 of our municipal solid waste. These images just show an example of closed versus open loop recycling. In closed loop recycling, that would be the idea that you would take a carpet, that carpet would be recycled into the individual carpet fibers, and a new carpet would be made. So it's a closed loop. You start with the carpet, you recycle it into a carpet. An open loop example would be, for example, if you recycle a plastic bottle, that goes to the waste recovery and processing site to get those plastic fibers, and then those plastic fibers may go into like an athletic shirt that contains a little bit of plastic. So you start with one thing and you end up with another. That's an open loop, just 2 different types of recycling. You may have seen some of these advertisements in like billboards of the subway This is an example of open loop recycling. This is that aluminum can saying, I want to be a bike, please recycle me. The aluminum can would be recycled into the aluminum frame of a bike. So this is open loop recycling. Some good news is, as the amount of municipal solid waste has increased over time, so has recycling. So this graph shows the total MSW recycled in that blue line. So as we generate more waste as a society, we also have been recycling more, which is good news. However, recycling requires time, processing, cleaning, transport, and modification, all of which require fossil fuels and energy use. So recycling is not perfect for the environment. It's better than it ending up in a landfill, but recycling does take a lot of energy to recycle something. So again, reducing and reusing are the better options. Recycling can also be pretty confusing to some people. A lot of people don't know what they should recycle or not. So many people are what we call opportunistic recyclers. They're trying to do good by the environment, so they end up just recycling everything, even though a lot of things cannot actually be recycled. Examples that I see people recycle all the time: napkins, you can't recycle. When we're eventually allowed back on John and you maybe go to the cafeteria and you get a salad in a plastic container, you shouldn't recycle those plastic containers if they still contain food in them, because that soils the entire recycling, and oftentimes then the recycling needs to be completely thrown away. So these plastic containers actually need to be rinsed out. Plastic bags you can't recycle. One thing that just used to drive me crazy in my old apartment building was people would collect all their recycling in grocery bags, in plastic grocery bags, and put that plastic grocery bag filled with recycling in the recycling bin. Well, then that's all going to get thrown away because you can't recycle those plastic bags. One thing that I did not know before I started looking into this more, and this is kind of specific to New York, is a lot of times we'll get like Starbucks or takeaway coffee, for example. That coffee cup can be recycled. You take off the plastic lid, that goes in the plastic recycling. If you rinse out the paper cup, that can go in the paper recycling, as well as a paper sleeve. This paper cup contains a waxy substance, so some states don't allow you to recycle the coffee cup, but New York City, our recycling plant is able to handle that type of cup, so you can recycle a coffee cup in New York. So just keep that in mind when we're back on campus. One thing to also be aware of is that there are many different types of plastic. A lot of times we want to recycle everything that's plastic, but all plastic is not the same. So some is more like junk, like flimsy plastic, like that example of the salad container is really not very high quality plastic. The United States used to sell this bad plastic, or China used to take the bad plastic from the United States and they would recycle it and reuse it over in China. But just recently, they have said, we do not want to take your bad junk plastic anymore. You can keep it. So now the United States has all of this plastic just piling up in these recycling facilities, and we're not able to recycle them. We're not able to sell them. We're not able to convert them into a new product. So it's really just sitting around until we come up with a new way to recycle these into more high quality plastics. So a lot of times we think we're recycling things and they just end up in these recycling plants sitting there for forever because they can't actually be recycled. So if we're not throwing something away, if we can't recycle it, one other way we can reduce our waste is through composting. So compost is organic material that's decomposed under controlled conditions. So this includes things like vegetables, vegetable byproducts, so like apple cores, orange peels, grass, animal manure, yard waste, so like grass cuttings and tree trimmings, paper towels, egg cartons. So these are all things that are biodegradable, that break down in the environment, and they're perfect for composting. Typically, we don't include meat or dairy products in this list, just because they can kind of attract rodents and they don't smell very nice when they're composting. But any other food product, paper product is perfect for a compost pile. So these are just examples of what a compost pile would look like, from the very simple to the more complex. Composting ultimately is going to produce organic rich material that can be used as a really like a fertilizer for your gardens and for agriculture and improve soil fertility. So compost can be as simple as a pile of food and yard waste in the corner of your yard, like for example, where you would just pile on your old food waste, yard scraps, and paper products. You leave that, and over time, it's going to break down and form this really rich soil. You can have these more complex containers where you would put your food scraps, for example, in, and these containers allow you to rotate them, which speeds up the composting process. Some people just have a little container on their kitchen counter to collect all their food scraps, and then they would bring it out to a special compost bin. I know that composting is something that is being rolled out in New York City, so some of you may already have a recycling bin, a bin for regular trash, and also a compost bin that's picked up regularly, just like your garbage and recycling is, which is great. I hope that's expanded throughout the city. So food scraps, spoiled food, paper, yard trimmings, plant waste, this is all the organic waste that it can be composted, make up 1/3 of the waste that is picked up by the New York City Department of Sanitation. So if we can put this waste into compost and use it to create soil that can be used to fertilize our farm fields instead, that would be one way to vastly reduce the amount of waste that ends up in a landfill. So if we can't compost, if we can't recycle, reduce, or reuse, then that waste is going to end up in a landfill. Landfills have replaced open dumps in the developed world. So in more developing countries, open dumps are still more common than these very highly engineered landfills. I'll show you a picture on the next slide. In the United States, 54% of our waste ends up in a landfill, 33% is either reused or recycled, and 13% is incinerated, so burned. I'll talk about that as well in a second. So this is an image of a landfill. Landfills are highly engineered, very technical structures. They hold municipal solid waste, the whole goal being to minimize contamination with the surrounding environment. So this is what you would see in the United States. In more developing countries, instead of these sanitary landfills, you often see more of an open dump where the individual pieces of garbage are, visible. The waste is not segregated from the surrounding environment, so it can very easily contaminate the groundwater or the surrounding soil. One thing landfills are very good at doing is collecting leachate. So leachate is the water that's contaminated by traveling through that solid waste, and it picks up various chemical compounds. So picture water raining on top of that open dump, and as that water percolates through that open dump, it's going to pick up all of the toxins, all of the waste in that dump, and that water is called leachate. It's very toxic water, and you want to prevent that leachate from leaching out into the surrounding environment. Some things make the leachate especially toxic, like paints, motor oil, antifreeze, electronics, and so that's why those items are especially important to keep out of the landfill. This is just a cross-section of what a landfill looks like, so you can see some of the engineering that goes into it. Landfills often have these clay liners to protect the waste from the surrounding environment. They often have leachate collecting systems at the very bottom of the landfill. So once that rain falls onto the waste and it picks up all of the toxins as it travels down through the landfill, that toxic water, that leachate, is then collected by this sewage system where then it can then go and be treated. Once the landfill is full, it is capped. So you often will see these, it will put soil on top and then plant some grass on top, and then they move on to the next location. This is a picture of the old Fresh Kills landfill on Staten Island, which was once the largest landfill in the United States, one of the largest man-made structures in the world. And this is no longer a landfill, so this is an example of a capped historic landfill, and the idea being that they want to produce more recreation and green space in Staten Island. So this is just goes to show, this is an artist rendering of what the landfill will look like in the future with trails and parks and rivers to kayak through. So if landfills are designed correctly, they do have a life after the landfill, and they really can be beneficial to the environment. So landfills are built at a very tremendous cost. They charge what are called tipping fees. So each truck that uses the landfill pays about $35 a ton. The idea being this should provide cities an economic incentive to recycle because it's so expensive for cities to bring these trucks to the landfill. Many communities don't want landfills in their backyard for obvious reasons. It decreases their property value and for aesthetics. This is a term you often hear in environmental racism and environmental injustice, which is NIMBY, which stands for not in my backyard. Oftentimes these landfills end up in communities of people of color or poorer communities, which, like I said, is tied very closely to the whole idea behind environmental justice. So in New York City, our trash ultimately is shipped out to upstate New York, New Jersey, Pennsylvania, and Virginia. So we send our trash to these other states. We pay these other states to take our garbage in New York City. One other option for how we can dispose of our garbage rather than a landfill is through incineration, which is the idea that you're actually going to burn the trash to reduce its volume rather than send it to the landfill. This sometimes is able to generate electricity, so you can use this as electricity production. Sometimes the ash that's produced from the incineration process can actually be used in construction, in like building roads, for example. A couple problems with incineration of burning the trash. It's extremely expensive to do this, so almost twice as much to just dump the trash at a landfill. There are many NIMBY issues behind this. If you didn't want a landfill in your backyard, you really don't want an incinerator in your backyard because it can lead to a lot of air pollution. And oftentimes the ash that's produced is actually more concentrated and maybe more toxic than the original waste. Anytime you concentrate the waste into a very small volume, it may be more toxic. I just want to talk really quickly about a specific category of hazardous waste, a specific category of waste known as hazardous waste. So this is liquid, solid, or gas or sludge waste that is harmful to humans or ecosystems, and it requires special means of disposal. This is the type of waste that we generate in labs at John Jay. Hazardous waste. It's a very specific category of waste. So hazardous waste, this is a label that you would see on a waste bottle that we would generate in labs. Hazardous waste is either waste that's corrosive, so it eats through metal, it's ignitable, it catches on fire, it's reactive, it can explode, or it's toxic, it's dangerous to people or animals. So this is a very specific category of waste. Hazardous waste is really expensive to handle. In order to get rid of this waste, you need to call in very specific companies that take the hazardous waste from the lab. They test it to make sure it is what it is, and then they dispose of it safely. Not in a landfill. They need to dispose of it in really specific, very specific, expensive process to discard of this hazardous waste safely. It's expensive, and so the whole idea is we want to generate as little amount of hazardous waste at our university as possible. Okay, so hazardous waste ties into the idea behind a Superfund site. Remember, this is going to be the idea behind your research paper in Sci 112. You're going to be discussing about Superfund sites in New York State. So a Superfund site is land in the United States that's been contaminated by hazardous waste. So remember, hazardous waste is waste that's corrosive, toxic, ignitable, or reactive. So it's land that's been contaminated by this hazardous waste, and it's been identified by the EPA for cleanup because it possesses a risk to humans and or the environment. So this is a map that just shows the location of the Superfund sites around the United States. Every single state except for North Dakota has Superfund sites, and they are really concentrated out here on the East Coast. So some examples of Superfund sites near us, the Gowanus Canal. Gowanus Canal is one of the most polluted waterways in the United States, mainly because of so many industries that are built up alongside the Gowanus Canal, and they historically have just dumped their waste into the canal. The Gowanus Canal is extremely toxic. This would be a great Superfund site for you to write your paper on. Sorry, my computer's being slow, moving to the next slide. Okay, similar to the Gowanus Canal is Newtown Creek. You could also write your paper on this Superfund site. Newtown Creek is near Greenpoint in Brooklyn. Similar issues, industries have been dumping their toxic material into Newtown Creek for decades, resulting in one of the most toxic waterways in the United States. Okay, so another Superfund site that you guys could talk about is the Hudson River, actually. So especially north of the Hudson River, General Electric have been dumping chemicals called PCBs into the Hudson River, which are extremely toxic. So the Hudson River is a Superfund site. Not all Superfund sites are waterways, even though the couple examples that I just gave are waterways. There is another Superfund site near us in Ridgewood, Queens, that you guys could write your report on. This is an area that a chemical company used to dispose of radioactive waste into the sewers. And so the land around this specific block in Ridgewood, Queens is considered a Superfund site. So just to finish up, another category, not Superfund site, there's also areas of land in New York City called brownfields. These are commercial sites that require cleanup before they can be developed or expanded. So these are like old factories, dry cleaners, gas station, landfills, and rail yards. If you want to build, for example, a condo on a site that used to be an old dry cleaner, that land is considered a brownfield site, and that land needs to be cleaned up and given the okay that is an environmentally safe before you can build on that land. So this is a really common category of land that we have in New York. So in terms of your report, I really just want you guys to pick a Superfund site near us. Those would be my recommendations. Ridgewood, Queens, Hudson River, Gowanus Creek, Gowanus Canal, or Newtown Creek. But you guys can pick any Superfund site that's interesting to you. So in the end, in terms of waste management, we really need to come up with a holistic approach that tries to reduce waste, manage waste, and come up with new and innovative disposal strategies along the entire chain of waste, from when it's generated to when it's ultimately disposed of. So in terms of manufacturing, we need to start changing our package design. We need to change our manufacturing practices. In users and consumers, we need to change our own purchasing habits. We need to maybe start composting so we reduce the amount of waste that goes in the landfill. We need to increase how the products we reuse. When we look at waste, we need to try to recover more of these products for recycling. We need to improve our composting. Ultimately, the idea is to decrease the amount that ends up either incinerated or in a landfill. So we each, all the way from manufacturers to consumers, have a role to play